In this video, we are going to practice functions, check our knowledge to see how well we understand functions. There are kind of interesting questions we are going to solve. Okay, let's start. Question number 1. Here is your graph, ax squared plus graph of the function ax squared plus bx plus c. You don't have anything, you just have the graph. Find the value of a. Okay, so what do we have? We have the minimum point here, right? Let me open it. Yeah. We have the minimum point that has -1 and +2 coordinates, right? -1 and 2, correct? Now, when we have quadratic equation of the format ax squared plus bx plus c, vertex is equal mean negative b over 2a, and then function of negative b over 2a. So here is my a, here is b, here is c, right? Coefficient. Okay, well, let's see. When we say minimum, this is my x, right? And this is y. Here is also, this is x is this one, and y is this one. Excuse me. Okay, so for the minimum vertex, it's a minimum, correct? So I can write down from here that negative b over 2a is equal -1. Yes? From here, I can insist that b is equal +2a, right? All right, so we have the value b that has 2a. Now let's figure out, I'm going to find out c, because once I find this b, I find this c, I can find a. So how much is my c? What is my c? C is a y-intercept, meaning where the graph of the function is crossing y-axis. Here it is, this is where it's crossing. This is my c, and it's +3, right? So from here, I'm going to plug all these values into our y is equal ax squared plus bx plus c. Let's work on this side. Ax squared plus bx plus c. And that is equal y, right? Okay, so we don't have our a, we leave it alone, a. How much is I'm taking my x and y? I'm going to use, let me see, where is it? I'm going to use this coordinate for the minimum. So it's gonna be my x squared is gonna be a times -1 squared, right? Plus, how much is my b? b is equal to a. So I put plus 2a, and my x is -1, right? Plus, how much is my c? It's 3. And all this is equal 2. Where from this 2? That's a coordinate of y, right? We used the coordinate of x as a -1, right? Where the minimum is -1. And accordingly, the y for this -1 is my -2, my +2. That is my y. Okay, from here, let's find our a. So that is equal 2 is equal, I'll just rewrite the value of y, I'll put on the left side, is equal a minus 2a and plus 3. So from here, a is equal, because we have here like terms, right? A is equal, how much? 1. A is equal 1 from here. So the answer is going to be this one, 1. Okay, moving to next question. Here is given y and asking for value c. Well, it's already marked down, but c, what is this c? C is our intercept, right? Where it's crossing the y. So the value of c is going to be equal 3. So this one was pretty straightforward. Okay? Next. So here we have graph, inverse graph, k over x. So we need to find the value of k. We don't have anything else. All we do, we need to find value of k. Okay, let's take some point. Let's say point this one, -1, +1. All right? So plugging in y and x, 1 is equal k over -1, right? So from here, k is equal -1. Pretty straightforward. It seems from the beginning when you are looking, it's like very confusing. There is no information, nothing else. How to find it? See how easy we found it. Moving to question number 4. All right, here we have statements and we need to find it, if it's true or false. So here we have function, f of x. So we need to find if function is increasing indeed. Question number 1. Function, it says, is increasing on interval -2 infinity. Where is my -2? It's right here. -2 and positive infinity. Is our function increasing on this interval? Absolutely not, because here we have decreasing. Here we have increasing, right? So this is false. Okay. Next. It says f of 3 greater than f of -3. Let's find question number 2. F of 3, where is my f of 3? 1, 2, this is 3, right? +3. And here is 1, 2, 3, this is -3. So how much is, what is the value of y here? F of x here. It's here, something negative. 1.5, some -1.5, right? Yeah. And the y here, this is -3. It's positive, high positive. So it says the f of 3 is greater than negative f of 3. Absolutely wrong, because f of -3, look at how high it is. It's greater than f of -3. F of +3, right? Okay, so this is also, we don't accept, it's false. Okay, next one. F of 0 is equal -2. Where is my f of 0? X is 0. How much the value of y, f of 0? Negative 2, right? Right here, negative 2. So this coordinate is 0, negative 2, which means finally we got some correct answer. We agree with it. Next. It says at the line y is equal to, let's provide this line. Let me get thick. Line y is equal to crosses function in the point negative 2 and 2. Okay, let's see, where is it? This is negative 2. Okay, this is positive 2, all right? Here we have negative 2, positive 2, and crosses function at the positive 4 and 2. Let me see. 1, 2, 3, 4. This is my 4, but the graph, the y for here is 1, crosses here at the point 4 and 2. Yes, that's correct. 4 and 2. Doesn't necessarily has to be on the graph. We are not looking necessarily on the graph. It just says point. Oh, okay. I'm saying and I'm wondering. No, of course it's not the graph. It says line. Oh, line 2. Yes, yes, yes. It's correct. Sorry. Line 2. I was looking at the graph crossing. So line 2 is crossing 4. 1, 2, 3, 4. 4 and 2. Okay. Next one. Question number 5. Which statement is true? Let's look at the graph. Function increases on interval negative infinity to negative 1. Here is 1. And function is increasing from negative infinity to negative 1. Is the function increasing here? Let's see, on this interval. So the graph is going like, indeed, it's increasing all the way to negative 1. Okay, check mark, positive. And number 2, highest point of function is 8. Is now highest point. What is highest point of function? Is this point, right? Highest one. And this is 9, not 8. So this is red color. And lastly, f of negative 4. Let me clean this so we can work further. F of negative 4 is not equal f of 2. Okay, let's find negative 4. Here it is. And let's find f of 2. What is the value of y at the point negative 4? It's 0, right? So here we have negative 4 and 0. What's the value of 2 here at the point of 2? What's the value of y at the point of 2? So again, 2 and 0. So y is the same, right? Which means they are equal, and we reject this condition, this statement, rather saying. Moving to question number 6. True or false? What do we have? F of negative 1 is equal f of 3. Where is my negative 1? Here. Where is 3? Here. Indeed. The y in this point is 0. Yes? Green check mark. That's true. Next, highest point of the function is 3. Is that true? This is my highest point, and if I come here, it's 4. Rejecting. It's not 3. It's 4. Next, f of x is greater than 0 between negative 1 and 3. Between negative 1 and 3, f of x is greater than 0. Is that true? Yes, the entire graph, I mean not this piece of graph, is positive, right? We are not, don't get confused. We are not talking about increasing. If it would ask decreasing or increasing, then we would reject because the graph and increasing and decreasing on this interval. But from the point of positive f of x greater than 0, yes, that is true. The graph is positive. The function f of x is greater than 0. So green check mark. Moving to question number 7. Okay, highest point of the function is 9. Finally, we got green check mark for such statement. Indeed. Now, f of 0 is greater than f of 1. So, let's see. F of 0, this is my 0. How much is my f of 0? 0.8, right? Correct? The coordinate is 0, 8 here. What is f of 1? F of 1 is somewhere here. So 8, 7, 6, 5. So it's going to be 1 and 5. As we can see, 8 is greater than 5, which means we're getting green check mark. Yes? And lastly, f of x greater than 0 when x, let me see, x greater than 0. So x is greater than 0. Let me see. X is greater than 0. And, well, is that statement true? Absolutely not, because look here. Here we have x is still greater than 0, but how about this piece? Going down, negative, right? It's negative, so it's getting red check mark, rejection. Oh, wait a minute, it says less than 0. Okay, well, I analyzed greater than 0. Now let's analyze less than 0. It won't hurt, so let me clean this, since I don't know what it is, if it's true or false. So less than 0, when we have less than 0, so the value of x growing from negative infinity to 0, right? Okay, the same picture is here. Look, it's negative. It's not all constantly positive. This piece, let me see. This piece is, yes, positive. Oops. It's positive, correct? All the way to x is 0. But here, it's going negative. So, rejection again. So across the x line, you can say the function is positive. I mean, f of x is positive because f of x is negative also. It's going down, right? Question number 8. So what we are going to do here, we are given quadratic, the graph of quadratic equation function, ax squared plus bx plus c, and we need to find at what given interval is increasing, at what given interval is decreasing. So let's see, 1 and 2, this is my 1. This is my 2, right? This is my interval. What's happening to function on this interval? Decreasing, yes? Look, decreasing. So we have here, this is matching to decreasing B. Next, between 0 and 2. 0 and 2, here is my interval. What do we have? We have it increasing here. We have it decreasing here, which means it's matching A and B, both of them, right? Next, -1, 0. On this piece, what is happening here? Decreasing, see? It's decreasing, so this one is going to be B. And the fourth one, -2 and 3. -2 and +3. This piece. So again, it's increasing and then decreasing, right? So it's going to be and A and B. Since it's asking only where it's increasing or where it's decreasing, so we are scratching these ones, or rather saying instead of scratching, we check mark. Its answer is going to be this one, first one, and fourth one. I'm sorry, third one. Okay, first one and third one. Question number 9. We have here functions and their graphs. So we need to match up 4 graphs, 3 functions. Yes? A, B, and C. All right. So what do we have? Let's see. Let's take A. -2x plus 4. All right. -2x plus 4. Let's write down the format. Y is equal mx plus b, right? Where b is showing vertical shift up and down, and m is showing slope. If m is positive, graph is increasing. M is negative, graph is decreasing. So we have -2x here, right? A. If it's -2x, that means it's either going to be 1, because it's decreasing, and it's going to be either going to be 4. How are we going to identify which one is it? We're looking at here vertical shifting. Vertical shifting here we have +4. So where it's crossing our y at the point +4 here. This is, it's not crossing positive, it's negative, which means 1 is falling off, and the answer here is going to be 4. So that is going to be A. Next, B. Y is equal to 2x minus 4. Okay, it's positive. Our slope is positive, which means it's going to be either second one or third one. So how are we going to identify? Actually, we can combine and look. B is, both of them, B and C, have 2x. So one of them going to be B, one of them going to be second graph, one of them going to be third graph. So we are looking at their intercept, y-intercept. Here we have -4. Here we have +4. Where do we have +4? Right here, which means this is our C. Where do we have negative 4 right here. That means this is our B. Okay? Okie dokie. And the last one. So, we are given the graphs of function y is equal ax squared plus bx plus c. So, for each graph, we need to match up appropriate A and D. Let me remind you, A and D. For ax squared plus bx plus c, when we are solving equation, a function, a quadratic equation via discriminant, remember that, let me write down x12 is equal negative b plus minus b squared minus 4ac and divided by 2a. So, most importantly, the discriminant is what we call b squared minus 4ac. This is our discriminant. Now, here is the rule. If discriminant is greater than 0, then we have two solutions, two x's. When discriminant equals 0, then we have one solution, one x. When discriminant is less than 0, we have no solution. Okay? And about a, we know when a is greater than 0, graph is going up. When a is less than 0, graph is going down. So this is leading coefficient a tell us if graph is going up or going down. Okay? So let's see. Let's analyze and figure it out. Before I start matching up, the easiest way, identify A, B, C, D, each one, which combination belong to. Let me change it. I have here in Russian language written because I'm running Russian channel also. A, B, here is C, and this is D. So, let's look at the graph A. What do we have here? Do we have two solutions? How do we know if we have two solutions? Because it's crossing into points. So if we have two solutions, that means our discriminant is greater than 0, right? 2 points here, two x-intercepts. That means it has two x's, two solutions. How about A? The graph is going up, right? That means A is greater than 0. Next one. Does this graph crossing anywhere x-axis? No. Which means here the discriminant is less than 0, right? And our coefficient A is still greater than 0. Okay? Wait a minute. A greater than 0. Third one, what do we have? Discriminant is less than 0, right? Because it doesn't cross x anywhere. And A is also less than 0 because it's going down. And lastly, we have here 2 points. Discriminant is greater than 0, right? Crossing in two x's, that means has two x's. That means discriminant is greater than 0, positive. But A is going down. A is less than 0. Okay, let's identify which one is matched to which one. So A, we have D greater than 0, A greater than 0. Which one is that? It's number 1, okay? This is A. Next, D less than 0, A greater than 0. A greater, here it is, B. Because D less than 0, A greater than 0. Next, D less than 0, A less than 0. Here it is, number 4 is C. And D greater than 0, A is less than 0. This is going to be our D. Okie dokie. I hope you enjoyed it. It was, I like the questions. They were really testing the knowledge, how well you understand graphs. So if it helped you, I am glad. Okay, so see you in next video. Okie dokie. Bye for now.